The Goodwood Revival functions as a longitudinal study of surviving design. Across 3 days, it provides physical evidence of which design decisions survived contact with 4 decades of weather, use, and repair. The first machines on track each morning are hundreds of original, pre-1967 Vespas, sharing the paddock with the largest gathering of Maserati 250Fs in the world. These mechanics and drivers are racing, judging, and photographing every single one of these machines in a physical condition its original designer never signed off on. The modern design industry often misses this. We design cars, render them, and launch them in exactly one state, brand new, unrained on, and entirely unparked. That state lasts for about a week. The next 40 years, the material reality that actually decides whether anyone still wants the object happens outside the design process entirely. The highest tier of the collector market has moved to reward original craftsmanship and preservation over the sterile quality of a modern restoration. This shift is visible in the 2024 Pebble Beach Best of Show Award. It went to this unrestored 1934 Bugatti Type 59, the first preservation car to ever take the award. This shift is supported by technical standards like the FIVA Charter of Turin, which maintains a formal vocabulary for original paint and a rigid judging scale that penalizes intervening with a vehicle's history. While the historic market demands physical reality, the modern design industry relies on CGI. We now place cars on mountain passes in digital environments before the first body panel is even pressed. This creates a statistical anomaly. An explosive volume of factory-fresh imagery exists, while the number of visualizations showing that same car at year 12 remains at 0. By outright replacing photography with CGI, the industry has trapped itself in an illusion, designing for a pristine state that survives for only a single week. Physical design follows a core rule. Materials do not simply age in place, they travel towards specific destinations. Materials like vegetable-tanned leather, brass, and oiled timber move towards states people find desirable. Over time, they become darker, softer, and more specific to their owners. Other materials move toward destinations nobody likes. Piano black lacquer, chrome effect plating, and soft touch coatings eventually become swirled, clouded, sticky, and start lifting at the edges. This side-by-side comparison shows those two trajectories. Path A maps the graceful maturation of natural materials, while Path B tracks the rapid physical degradation of synthetic coatings over the same multi-decade timeline. Failing to anticipate which path a material is on ensures that the product will eventually look like damage rather than heritage. That aesthetic failure is now a legal liability. In July 2026, the EU Right to Repair Directive became applicable across the continent. The mandate obliges manufacturers to keep spare parts available and ensure products remain repairable for up to 10 years. A component that must still be replaceable in year 10 is a concept phase constraint. That 10-year requirement traces straight back to a specific week at a designer's desk. The current workflow allows the choice between a material that ages gracefully and one that degrades to be made by the same person in the same week, looking at a single pristine render. Regulators now check longevity as a property of the design, yet that destination is often decided on day 1 by someone visualizing the wrong version of the product. The concept phase exists specifically to answer design questions cheaply, long before anyone commits to a physical manufacturing tool. The most vital question is not whether a material looks premium on the day it ships, but which direction that material is heading over the next decade. This graph shows the input costs. It costs nothing to render the same surface at year 1, 10, and 30, while tooling is just a drawing. Compare that to the expense of learning years later, when failures erupt as warranty data. Time must be treated as a load-bearing design property, just like structural integrity and weight. A visual cue that photographs well when new, but reads as physical damage by year 8, failed the moment it was designed. That degradation is predictable and knowable before any commitment to a physical tool is ever made. Design decisions are cheap as a sketch, but brutal once tooled. To build something that survives, you must see every year before you start building. Depix builds generative models designed to solve this consistency problem, allowing design teams to simulate exactly how their materials will match a product's real-world future. It is about bringing longitudinal design intelligence into the concept phase.